Hi and welcome back. In this video I wanted to talk about a really important concept in programming, which is mutability. Some things in Python are mutable and some things are immutable. So what is mutable? A mutable piece of data is one that you can change after you've created it. An immutable piece of data is one you cannot change. Now, here you may be wondering, aren't all pieces of data mutable? Like, when you create a variable, you can then change it? Yes, that is true. However, the variable itself is not the piece of data. Let's go back to our dictionary that has how long ago we saw some of our friends. Here, the data is the dictionary. So Python creates this dictionary, and then the variable is essentially like a post-it note that's been attached to the variable to the data that says this piece of data now has this name. However, when you do something like another variable equal friends last seen, these two are the same dictionary. Once again, what we've done is we've attached another name to the value in here, this dictionary here. This is a really important concept in programming. Let's forget about this name tagging for just a moment, and I'll ask you, how do you know it's mutable? Well, whenever we create a new dictionary, it's stored physically in your computer's RAM, random access memory, which is a type of memory that only lives while the computer is on and your app is running. As soon as your app terminates, your program finishes, i.e. if we run this and it reaches the end, the RAM does get lost, or rather the memory that was assigned to this Python program gets lost, and then it can get overwritten by other programs. Python can give us the ID of the object. The ID function here is used to give us the ID of any object, and in this case we're passing it the friends last seen variable here, which points to this dictionary. So it can give us the ID of that, and in the majority of Python implementations, that's an interesting concept by itself, but in your Python implementation, the one you'll be running most likely, and certainly here in REPL it, the ID is the address of the object in memory, and that's precisely the first cell in a group of cells in your RAM which stores your object. This ID function here gives you the first cell in the group. That's because the object can take up multiple cells, and they normally do. Okay, so let's run this program. And now you get a number. Seemingly arbitrary number, but when we run the program again, notice that we get a slightly different number. It wasn't so easy to see, but trust me, it's a different number. Now, when we say friends last seen is now this dictionary, which looks the same, but is an entirely new dictionary, and you can tell that by, once again, calling the friends last seen function, the ID. Notice how these two numbers are very slightly different. That's because these objects are not the same object. They are two objects which have the same content. Think, for example, of two cars coming out of a production line. They both have four wheels, a steering wheel, they both may be red, they both be the same make and model, but they are not the same car. Same thing here. We have a variable which has a name, and that is assigned to this dictionary here, this particular object, and then we get the ID of it, then we assign it to another dictionary which looks the same, and get the ID of it. And those two dictionaries are created one after another. The reason why this dictionary cannot have the same ID as this one is that when the time this is created, at the time this is created, this one still exists, so it cannot possibly appear in the same place. The other one's taking up the space. Okay, so even though the dictionaries have the same values, their ID values are different. New dictionaries were created each time, and hence their memory addresses, what the ID function returns, are different. However, what if we do this? We create a new dictionary here which has an entirely new ID, and then we say friends last seen, Rolf is now 0. what do we think this is going to print? Is it going to print an entirely new ID, or will it print the same ID as before? Well, it doesn't really matter what you guessed, but what matters is that the ID will be the same. As you can see, these last two numbers here are identical. That's because when we run this line of code, we have modified this object. We have not created a new object, we have mutated it. This is a mutable data structure, the dictionary. Okay. This is the case with many things in Python. When you create your own classes and you change a property of your objects, you're not creating new objects, you're just changing something that is already there. However, there are a few immutable things in Python. Integers, for example, are immutable. Let's say that you get my int, and that's 5, and then you say id or print id of my int. When we run this, we'll get an ID for our integer object. But how can we modify the 5? You cannot change 5. 5 is always 5. If you make it 6, that's an entirely new thing, an entirely different thing. So, indeed, if you do my int is equal to my int plus 1, and then you print the ID of my int, that's going to be an entirely different value. And as you can see here, it's pretty similar, but it's not quite the same one. So integers are an example of something that is immutable. You cannot change it, because 5 is always 5. Other things that are immutable are floats, strings, and tuples. You cannot change tuples, for example. Okay. Lists, however, are mutable, and I'm going to show you an example. Let's have a friends list, Rolf and Jose. Then we can print the ID of friends. We can then do something like append, and then we can print the ID of friends again. And now notice how these two will have the same ID. We've got 5 values here, so we'll now get 7, and these two down here have the same ID exactly. We've changed or mutated the list, we have not created a new list. When you use list comprehension, for example, a new list is created. So these are the immutable types in Python. Integers, floats, strings, tuples. And there's not many more. In fact, I don't know any other immutable types. So what is really happening when we mutate an object? Yeah, maybe you can see a pattern here, which is that we've got a mutable type, and then here, but this is our mutable type in this case, the dictionary, and then here we're mutating it. So what's happening here on the innards of Python? Well, this is happening. Friends.scene, set item. A function is happening. A function call is occurring. This function call here, that takes in self as an argument, is modifying the self object. It is not creating a new dictionary, which you would do with, like, you know, creating a new dictionary. You'd be like, yeah, Rolf is now 0. This would create a new dictionary. But this set item function is not creating a new dictionary, it is modifying self. That is why it mutates the data, it does not recreate it. So what happens when we do this? Well, something happens when we add myInt plus 1 together. This happens. myInt add 1. But the difference is the add function takes in the value of self and returns a new integer object, potentially something like this. I'm not exactly sure how the inargs work, but all I know is that it returns a new integer object. It does not modify self, which could be, for example, self.value plus equal 1. This could modify self potentially. Okay. Note that myInt plus equal 1 is another function call, myInt iadd self1. If the int object was programmed to create a new int object when this function call happens, then the int object would not be mutable. It would be immutable. Because this iadd function is programmed to create a new int object every time, the int object is immutable. You cannot change it. So, immutability. All functions return new int objects. You cannot change existing int objects. This is why some of these things are immutable and some of them are mutable. Because you create new objects of their type when you call some functions, and in other cases, you never modify existing objects, you only create new objects. This is the concept of immutability, and it's sort of difficult to wrap your head around it, but in the next video we're going to look at some examples of where mutability matters. So I'll see you in the very next video.